have left from this section and then make a decision. I think Tony just went out, but he had a question. He had a question on a problem, and I said to him when we started, not yet because we didn't get there. So when he comes back, I'll ask him again. I think it's something similar to H. So we should do H, and let's read the other 4 problems and decide what to do. If you say we should do all of them, we'll do all of them. Okay, find the values of M and B. These are the parameters M and B. That make f differentiable everywhere. That's one question. Find a second degree polynomial such that blah blah blah. Conditions are given to us. Find the derivative of the following function given, oops, so please, I swallowed an N, I was hungry. Given that f of x is a differentiable function. And then problem 58 on page 190, which you had for homework, but I'm more than willing to go over it in class. So what would you like to continue with? The top. Very good. Well, let's continue with that. So we're given a function, which is x squared. It's a piecewise defined function. And mx plus b for x greater than 2. Very good. We are asked to find m and b that make f differentiable everywhere. Differentiable everywhere. One of the topics from chapter 2 that we will review over and over is, put my handout away again. Yes, I did. Is the concept at the very last, on the very last page of this handout, number 5. Can anyone read it? If not, I will. Differentiability implies continuity. If a function is differentiable everywhere, it must be continuous everywhere. But is the converse true? We already have shown that 5 minutes ago, that this function was continuous everywhere, but it had this particular corner, cost, whatever you want to call it, and it was not differentiable at that point. Good. So keep this in mind. So then I come back and I ask you, how do I proceed? What is the first idea, first thought that comes to my mind? I'm given a function and I'm told, make it differentiable everywhere. Find m and b that is different, that makes it differentiable everywhere. So what do I do? I'm not there yet. That's why I reviewed the concept of continuity. Nope. So first of all, number 1, I have to write that x squared is continuous on the interval -infinity to, not closed to, since it is, thank you. Step number 2, I have to write that mx plus b, what? Yes, is continuous on 2 to infinity since it is a polynomial function. Step 3. What am I, Tony?
Why is 2 parentheses not a bracket?
Excellent, because I have not studied the continuity at that point yet.
Right.
I only said, in other words, x squared as a function, as a quadratic function, is basically continuous everywhere. But for this function, x squared is only between -infinity and 2, and you're right, including 2. But I haven't analyzed what happened at 2 yet. Okay. This is definitely a linear function. M and B are numbers, continuous everywhere, and also, of course, from 2 to infinity. Now, my step 3 is what? What am I doing in step 3? So I established that this is continuous and this is continuous, but I didn't establish that this is continuous. Say it again. Right, exactly. But what is my title now for number 3? What do I have to put in writing before I start with the limit? You're right. My title here. What am I doing? A continuity at? Exactly. Continuity at x equals 2. Now I'm ready. Continuity at a point. Please dictate. It's right here. That's why we review chapter 2 forever. Yes. Excellent. Yes, we hope. We'll see in a minute. Yes. Yes. Right. And we hope. Yes. Exactly. This is mandatory for differentiability, right? If it's not continuous everywhere, there is no discussion of differentiability. Correct? Perfect. So then, what do I write? How much is this? Yes? How much is this? Excellent. 2m plus b. Very good. How much is this? 2. 4. Very powerful. Ian is very powerful tonight. If he says 2, I write 2. So 2 is here. 2 squared. Don't tell me to jump from the 4th floor. Okay, very good. So this is my first equation. This has to happen, right? So these have to be the same. These have to be the same. No question there. Okay, so what is my first condition? What do I have to write? For the function to be continuous at 2, what has to happen? Very good. Must equal 4. There is no question about that. Good, excellent. Moving on now. So with this condition, definitely I made this function continuous everywhere. Right? We agree? Okay. Now I want to make it what? Right. The next step is I want to make it differentiable. So I'm going to write again. So this is item number 4. X squared is differentiable on negative infinity to 2 since it is a polynomial. Number 5. Mx plus b is differentiable on 2 to infinity for or since, for the same reason, right? It is a polynomial function, linear. 6. Give me a form for f prime without 2. Give me a form for x squared prime. Without the equal symbol I meant for a moment. 2x for x less than 2. Okay? And give me the derivative of the second branch. Very good. For x greater than 2. Notice again I did not put the equal symbol just yet. Now I want to make this basically a continuous function. So what has to happen now? Remember the unique tangent. I have to have a unique tangent. The function has to have a unique tangent at 2. So then the limit as x approaches 2 from the left of must equal the limit as x approaches 2 from the right of, and you tell me what? What goes in here? What goes in here? So how much is this? Good. How much is this? Very good. So here's my B condition. I have an A condition, and here's my B condition. What is my B condition here? Exactly. So now I put the A condition and the B condition together. 2m plus b equals 4 and m equals 4. And then I'll come back. I'll come back to this. It's not done. So I already have m equals 4. What should I do to get b? Plug it in right here. So then I have 8 plus b equals 4, so b equals -4. Now I can say this will definitely be differentiable, but now I have to write the function. I have not written the function yet that is differentiable everywhere. Can anyone dictate? Obviously x squared, 4x less than or equal to 2. And yes, 4x. Indeed. Wonderful. Indeed. 4x minus 4, 4x greater than 2. Is it guaranteed that this function is continuous and differentiable everywhere? Agreed? Good. Differentiable. That's good enough. Differentiable. I tried to write two things at the same time, and that's not possible. So that's good enough. If I say differentiable, I know it's continuous. It must be differentiable on -infinity to infinity. No. If you understood it, you will have no difficulties remembering it. So please practice it. Okay, I'm back. Here's the next problem. Find a second-degree polynomial such that blah, blah, blah. So I'm copying the information I have. So I have that p of 2 is 5, and p prime of 2 is 3, and p double prime of 2 is 2. Yes?
So in this case, you want to write the standard form of quadratic.
Yes, I'm waiting for a general polynomial degree 2. Yes.
X squared plus
Perfect.
our first equation, but 2.
Exactly. This is my first equation. P of 2 is 5. So this is 5, and I plug in 2. What do I get? 4a plus 2b plus c. This is my first equation coming from the first condition. What do I do with the second?
Differentiate that general.
Yes, I have to find p prime of x, which is
AX
2ax. I bring down 2 plus
B.
b indeed. And now this will give me the second equation. It says that p prime of 2 is 3. Let's plug in 2. So this is 4a plus b, 4a, and nothing else. So this is my second equation coming from the second equation that I was given. And then for the third one, how do I get the third one? Because obviously I have 3 variables, 3 parameters. I need 3 equations. So the second derivative, which is 2a, and that has to equal 2. P double prime of x equals 2. This gives us a 2a equals 2. And this is my third equation.
Where did the 4a plus 2b plus c equal 5? Where did we get that from?
2 times a times 2.
No, I'm saying the 4a plus 2b plus c was 5. Where did we get that from?
This one?
Yeah.
2 squared 4a, 2 times b plus c equals 5.
Okay.
Better? Perfect. So now we have 3 equations. 1, 2, 3. Let's put them together. Yes, Tony?
Why does the quadratic equation work there?
This is what we are told. Let's read the problem one more time. Find a second degree polynomial. Second degree means quadratic, and this is the general form of a quadratic polynomial. Something times x squared plus something times x plus something. Very good. Next. So I have now the system. 4a plus 2b plus c equals 5. 4a plus b equals 3. And 2a equals 2. I should have not even written 2a equals 2, but I copied all three. What do I know from here? Good. And now if a is 1, 4 plus b equals 3. How much is b? 4 plus b equals 3. Very good. -1. And now I plug them in the first one. A is 1, so 4. B is -1 minus 2 plus c equals 5. So this is 2. 2 plus what is 5? I determine all coefficients. There is only one polynomial that fulfills all the given conditions. Can anyone dictate that polynomial?
X squared minus x.
Indeed. Very good. Okay. Tony, when we talked about this, I just realized that I have a typo there, so I'm going to correct it. So I think that this is something that you were asking about, but with a graph. So let's do this one, and then we look at your graph, okay? Because we finally got to your question. Okay. So we are given x squared divided by f of x. We are told f is a differentiable function, and we are asked to find the derivative of this ratio. No. F. It's yes. Let's write the quotient rule.
2x times x.
No.
I mean minus.
Yes. No. Well, you're right. If you want to use that, that's fine. Over. No. Very good. This is it. We cannot do anything else. There's nothing else. And now we come to Tony's question, which I forgot what it was, but I'll find it. I think I'll... Oh, it was a graph, yes. Okay. Since I explain this problem all the time, and since I forgot to erase what I'm looking for, now I have to erase. I normally erase right away so I don't forget. Okay, perfect. Ready? It was 49, but I forgot which one. Tony?
I'm
looking for my pencil. Which one?
A and B.
Okay, so if f and g are functions whose graphs are shown, let u be f times g and v be f over g. Let's do one of them because the other one is the same. Which one? We're asked to find u prime of 1 or v prime of 5. Which one you prefer?
U prime of 1 sounds good.
Okay, very good. So u is a function that is a product. So I have to copy that. So u of x equals f of x times g of x. Again, this is problem 49 on 190. I have to find u prime of 1. What do I have to determine first? Exactly. I cannot plug in 1 if I don't have u prime of x. So, can anyone dictate u prime of x? Yes, g prime of x times f of x is good enough. Perfect. So now u prime of 1. Can anyone dictate u prime of 1? Very good. Very good. Of course, I replace now. I have the function. I replace x all the way with 1. Perfect. So now I need to identify all those numbers. So let's start with f of 1 and g of 1. F is in red. F of 1, how much? 2. A g of 1 in blue, how much? 1. So f of 1 is 2, g of 1 is 1. So this is 2, this is 1. Now, I need to determine f prime of 1. What does f prime of 1 mean? Yes, so this is the point, f prime of 1, and I'm trying to determine the slope here. I'm going to form a right triangle. So basically the best thing to do is to form a right triangle through the corners of the grid. So here's a corner, here's a corner, here's a corner. Rise over 1. 2 over 1 is f prime of 1. See it? Two rise over 1. It's a constant slope. It's a straight line. So rise over 1. So that's 2. Good. Now I have to determine g prime of 1. So go back to g. G prime of 1 is here. So through the corners of the grid, somehow, I create this right triangle. It's a negative slope, and it's 2 and 2. Rise over run. 2 over 2 is 1, but because it's negative 1. So this is negative 1. Yes?
Can you put the grid back up on the screen?
Yes.
So when we're trying, so for example, g prime of 1, how did you know to make that triangle as opposed to just going directly down 1 and over 1 and making that little triangle right there?
It doesn't matter. You can use any triangle you want. You can use this triangle. And it's still 2 over 2. You can use this triangle. And it's 4 and 4. Doesn't matter. As long as it passes to that point, and you look for the grid. So you can easily read. So therefore, I think this one, it's probably there. I'll get it. So this is 2 minus 2, which is 0. Any questions? Any questions? Let's also look at this, because I don't know if you got to this to work on this problem, but I think we should discuss it. Any questions? Okay, where am I? 58. Do I still have time? Yes. Yes. Right? Yes, of course. A manufacturer produces bolts of a fabric with a fixed width. The quantity Q of this fabric, measured in yards, that is sold as a function of the selling price P in dollars per yard. So we can write Q equals F of P. So one more time. Q is quantity, P is price. Q is measured in yards, P is measured in dollars. Right? in dollars per yard. So I need to write all this down. So this is problem 58 on page 190. So Q in yards. I know it's quantity. P, price, in dollars per yard. So we can write Q is a function of price. Then the total revenue of P, of the price, equals P multiplied by F of P. What does it mean to say that F of 20, part A, F of 20 equals 10,000?
That's 20 over 10,000.
So Q and F are the same thing. Q is a function of P. Q is quantity in yards. So this means what? F of P at the price of $20 per yard at $20 per yard. What happens then? The quantity produced and sold is 10,000 what? Yards. Is that clear? We agree? Okay. Part and also and F prime of 20, they say equals negative 350. Nobody told them to write measurement units. That's bad. But anyway, we are told F prime of 20 equals negative 350. This is definitely the rate of change of quantity with respect to price. Very good. And this is negative 350 what? Very good. So how do we interpret this? Here's how we interpret it. If the price increases from 20 to 21, what will happen to the quantity sold at that price? Will decrease by 350 yards. So let's write this down. If P goes from 20 per yard to 21 per yard, the quantity produced, sold, like the demand, if you want, decreases by, changes by, decreases by, is reduced by 350 yards. Part B. Assuming the values in part A, so remember those, find R prime of 20 and interpret your answer. R prime of 20 and interpret your answer. How do I determine an R prime of 20? How do I determine r prime of 20? What do I have to find first? Say it again. No. R prime of P. I have to find r prime of P to plug in 20 in it. Very good. So let's go back to the problem. And it says r of P is the product. P is the variable. A variable times f of P. So how do I find, so let me copy it here on this page. How do I determine r prime of P? The product rule, function times another function. P prime, it's x prime, in other words, is 1. So f of P plus P times f prime of P. That's the product rule. So then now, what do I do to this? That's the P, right? Multiplied by f prime of 20. And we are told to go back to what we already found out. So how much is f of 20? Plus 20. How much is f prime of 20? And what is the answer? Measurement unit. It's a rate of change. Yes, at the price of $20 per yard, the revenue changes $3,000 per yard. So how do we interpret this? So the revenue, so this was in dollars per yard. The price is in dollars per yard, and F is in yards. So this is just dollars. The rate of change of revenue. So, because we have yards, f of 20, we have to make sure the measurement unit. So f of 20, I didn't write it here. Why don't they write their measurement unit? That's so that's yards, yes, of course. So yards plus yards, f of 20. F of 20 is yards. This is dollars per yard. F prime, right? F prime. So this is yards and this is dollars per yard. So it's dollars, f of 20. Yes, but the price is here. Yes, it's 1. Yes, that's correct. Okay, very good. So how do we interpret this? All these measurement units have to be there. So how do we interpret this? When we increase the price from 20 to 21, what happens to the revenue? Increases by 3,000. Yeah. Good. I think that we had enough of this. What do you think? Do we have enough? Okay. Let's continue with I had a quiz for you today, but I'd rather, since we only have like 20 minutes left, I'd rather move on to 3.3 and we'll have a quiz on Monday. Okay? So the next section deals with derivatives of trig functions. We know the first one. We are dreaming about it. What is the answer? 1. We discussed that over and over. It's on the handout again. This, we will prove it, not today, but what I would like to do is either graph the function, or I worked on this function with my pre-calculus class. So I'm going to get rid of it. And I'm just going to write limit of what? I just want to determine that. How would you put it in, or how did you put it in? Cosine x minus 1. But be very careful, this has to be in parentheses as well. Okay? Divided by x, comma, when x approaches 0. Okay? And we will prove this together.
In our big group thing, do you want us to just have the answer, or do you want us to have the equation and then the answer?
If you just write this, it's good enough. If you just write this, I'm fine. So like I did it here. Now, if you want to graph something, it's a different story. If you want to, but that I'm fine with this. Good. So now we also know this, and I like to go through some of the limits here. We covered many of those in the handout, but let's go back. Limit as x approaches 0, sine 3x divided by x. And let me remind you, on Chapter 2 summary, we have this, which is a reminder that says these three things have to be the same and they have to approach 0. Then the answer will always be 1. So now I have to make sure that I have the same thing, meaning this piece, and this piece, they all have to be the same. If they are not the same, I cannot write 1. So, if this is 3x, what should I have in the denominator? Yes, and I will multiply the numerator and the denominator by 3, which is 1. I didn't do anything. But what should I have in here? Right, but since x approaches 0, and if you multiply both sides by 3, what will this equal to? Or 3x approaches 0. So when I say x approaches 0, I mean 3x approaches 0. It's the same thing. So now all these three things are the same. And now I can write that this indeed approaches 1. Therefore, the limit is exactly. Exactly. Any questions on this problem? Okay, next one. Cosine. Yes, Nestor, go ahead. Any questions? So I have cosine x minus 1 minus 1. Yes, Tony?
Can you just explain how it was 3 and not 1?
See, I only included this to be to approach 1, but I have a 3 in front.
Okay.
So 3 times 1 is 3. Better? Okay. Divided by sine x minus 1. So cosine x minus 1 minus 1. Sorry, I just went all over the place answering questions. Sorry about that. So cosine x minus 1 divided by sine x minus 1 when x approaches 1. Good. Algebra is a big part of calculus. So just remember, all I know is this. I know that limit from sine x over x as x approaches 0 is 1, and also the multiplicative inverse of this. Limit as x approaches 1 from x over sine x is 1. And I also know that limit of cosine x minus 1 over x is 0. We just looked at it a minute ago. So basically that's all I have at this point. So I'm looking at this limit and I say, okay, it's part of this and some part of this, right? So this piece appears to be coming from here, and this piece appears to be coming from here, the denominator of this. And then I don't have 0, but when I say x approaches 1 and I move 1 to the other side, x minus 1 must approach 0. When I move 1 to the other side, x minus 1 must approach 0. So if I tell you x approaches 1, I'm also telling you x minus 1 approaches 0. So now I do have the box, but nothing resembles, this does not resemble anything I have. So then I'm thinking of the following step. Rewriting, so I'm going to continue here. Limit x minus 1 approaches 0. And I'm going to write cosine x minus 1 minus 1 multiplied by sine x minus 1. I'm hoping that I can make this happen, and I'm hoping that I can make this happen. But what am I missing here, and what am I missing here? What should I have here? Indeed, because this and this and this have to be the same. This, and this have to be the same, and of course negative 1. So I'm missing an x minus 1. But if I multiply the denominator by x minus 1, I have to multiply the numerator by x minus 1, because these go away and they're 1. That's really all I needed. So remember, I have the box. Where does this go? Exactly. Where does this go? And where is the whole thing going? Exactly. Just a simple algebraic manipulation by separating the numerator from the denominator and creating two fractions, because this product and this product, they will be the same, right? Because I'm going to simplify these two. Yes?
What do we do with the minus 1?
Which minus 1?
In the cosine of x.
Better? If you remember, that's what we plugged in. That was the function. Cosine x minus 1 over x as x approaches 0. That's exactly what we had. Any questions? Are you with me? I know it's a lot. I know. Okay, let's continue with this. Cosine squared of 3 theta minus 1 over theta squared when theta approaches 0. Any questions before we continue? Oh, sorry.
Where did the extra minus 1 go?
This one?
Yeah.
It's here. That's the function we looked at.
Oh, okay.
So it has to have cosine x minus 1 over x. Cosine blah minus 1 over blah.
Yeah, okay.
Good?
Yep.
Okay. So the next one is limit when theta approaches 0 from cosine squared 3 theta minus 1 divided by theta squared. You can always go back to Maple and check all these limits. Always. Okay. Now again, that's all I have. I don't have anything else. So I'm looking at this and I see a cosine squared, which I don't have. I see a theta squared, which I don't have. So again, I'm hoping that with some algebraic manipulations, I can get this done. I'm gonna, like normally I should have said that when I have to plug in 1, right? So then the numerator is 0, the denominator is 0. So I have to think of other ways of addressing that. Okay, so the same thing here. When I plug in 0, this is 1, 1 minus 1, 0, 0 over 0. In the indeterminate case, question is, what do I do? Well, we do remember a very, I hope we remember the most important trig identity, that sine squared, okay, theta, equals 1. Excellent. Equals 1. Perfect. So now I'm going to try to get cosine squared 3 theta. Of course, if I have here 3 theta, is the same thing. Same thing. Sine squared of an angle plus cosine squared of the same angle equals 1. So I'm going to try to solve for this equation. So then I have cosine squared 3 theta equals 1 minus sine squared 3 theta. I'm going to put it up there. So this is limit as theta approaches 0. Instead of cosine squared, I'll put this 1 minus sine squared 3 theta minus 1 divided by theta squared. What do we notice here? Those go away. And this is more human now. The minus stays in front. I don't care for it. Sine squared. And maybe I should address it even better, putting the square outside. But then I have to take the minus in front. Because if I keep it inside, I'll change it into positive, and I can do that. Let's see if this is acceptable. Sine 3 theta squared is this. Theta squared is this. And the minus, I already put it outside. Because it still has to be there. I can change that. Now this is similar to something I see here. Theta, sine 3 theta, and theta. So I still need to make some adjustments. What is the adjustment I need to make? Multiply by 3 and divide by 3. So then this becomes now negative limit theta approaches 0 from 9 sine squared 3 theta over 3 theta squared. So what does this approach? Because 3 theta approaches 0 for sure. What does this approach? 1. Or 1 squared, which is the same thing. And then the limit must be, with a minus in front, negative 9. So if you want, you can try it with limit. And what do I have? It's cosine. You have to be very careful because I need parentheses around the top. And then I have cosine in parentheses 3 times x minus 1. And then in the denominator, I have x oh, what did I do here? Okay. And it was squared, yep. You're right. I jumped. Very good. Thank you. So I have power 2 minus 1, close the parenthesis, divided by, and that was x and I should put it in parentheses to be on the safe side, squared, and when x equals 0. Before I hit enter, I have to check my parentheses. So I have to have, and here's how I do it. So I have to have parentheses around here, have to have parentheses to have the power outside and parentheses inside, parentheses here, and the whole thing with a comma. So I'm checking now on my parentheses. Because I can hit enter and it's going to give me an error. So let me check. So cosine 3 theta, that is in parentheses squared, minus 1. Yep. So cosine 3 theta, and this is in parentheses, and then minus 1. I think I have enough. And divided by, I think I'm okay. The answer should be -9 or an error. Because I'm telling me that I missed something. Okay? Any questions? Any questions?
I just put this race I'm racing 200 too much with the mouse.
Oh. Very good. Okay. I know I have 6 minutes left. So limit x approaches 0 from tangent x over 4x. Yes, of course, the same thing. It is 0 over 0. What do I do? That's all I have. I can make this. So I'm hoping for that or for this. And I can make something like this from tangent. So then what should I do? So yes, indeed, very good. I have to do that. Sine x over 4x cosine x. Very good. Tangent is sine over cosine, and there is a denominator of 4x. Good. So then, where is this going? Indeed, we know that already. Where is this going when x approaches 0? Very good. So then the answer is, that's it. Indeed, 1/4. Limit as x approaches pi over 4 from sine x minus cosine x over cosine twice x. Yes, Tony?
Why are you going to just break up that fraction how we did?
You mean this one?
Yeah.
Because that's all I know. And I have to use what I know. I know that limit is of sine over x when x approaches 0 is 1. That's all I have. Because otherwise it's 0 over 0. But I know that when x approaches 0 from sine x over x, I know I showed it with a graph. I did not prove it yet. We will, using L'Hopital's rule. We will prove it. But right now we can't. We didn't have. Next time I will present L'Hopital's rule. Okay, when I plug in pi over 4, these two are the same. So it's 0. 2 times pi over 4 is pi over 2. Cosine pi over 2 is 0. However, I can make any of this up. I can. This is not helping right now at all. That's why I have to go back and dig deep in trig and remember what this equals to. Well,
Isn't it cosine
Yes?
x squared minus sine squared?
cosine squared minus sine squared. Yes. Cosine squared minus sine squared. It should be in the front cover or back cover of your book. So knowing that, and since we know a keyword here in this class, what is one of those two keywords? Simplify factor, simplify factor. I look at the top and I see sine, cosine, sine minus cosine. I will factor out -1, and I have sine squared minus cosine squared. What am I really getting at? Right, I have to factor this. This is on our contract. How do I factor this?
Sine of x plus cosine.
Exactly. Difference of squares. And sine x minus cosine x. Okay, now look carefully and say, I know what you're going to do next, and I am going to do it. They are the same. Now let's plug in again.
Wait, why is the denominator negative?
The denominator is not negative. I factor out -1 because I have sine x minus cosine x in the numerator, and I had to switch it. They have to be in the same order. So I factor out -1. -1 times sine squared is this. -1 times negative cosine squared is that. It's not the denominator. It's the whole fraction now. Yes. Very good. So then what next? Well, now when I plug in, the numerator is 1, and the denominator is sine pi over 4. Anyone remember sine pi over 4? The only angle that sine and the square root of 2 over 2. Plus the square root of 2 over 2. So the square root of 2 plus the square root of 2 is 2. 2 over 2 is the square root of 2. So -1 over the square root of 2. If you want to rationalize, you will write this. I will stop right here. Let me know if you have any questions.